Thanks for coming. Can everybody hear me okay if I hold the mic like this? Yes? Cool. First of all, I wanted to welcome you to TellApart. This is actually the first time that we've been over here in the new side of the building. So as Wade, our VP of Engineering, who's hanging out in the back trying not to look at me to make me nervous, said to me before the talk, big data and fast data have been good to us. So it's an exciting time for us to have an event here in the expanded office. I don't know how many of you walked over from over there, but we tripled the square footage of the office by opening up over here. So look forward to more events here at TellApart, and I'm excited to be up here talking at the first one that we've had on this side. Fast data driving personalization. I was talking to many of you before the event trying to figure out who this audience is and what you guys are interested in, and what I found is that you are a very heterogeneous group, ranging from data scientists interested in feature extraction and feature engineering and modeling algorithms all the way down to data engineers that are connecting the pipes together. I hope that everyone will find something here in the talk about one of TellApart's products, our retargeting product, and the fast data that we use to power it that will be interesting and valuable to you. I have a couple of goals, so let's talk about what I'm actually going to talk about today. The first one is the fast data paradigm. So fast data sounds like a buzzword, and I'll address that in a second. It's our buzzword, though. We are trying to drive it forward, and specifically what we're talking about is applying the Lambda architecture, something that Nathan Mars has proposed and other people have been adopting across the big data stack. To be able to do big data in a very fast, responsive way. So we're going to call it fast data for the purpose of this talk. The second part is diving deep into how we actually use fast data to drive a product forward and to drive a lot of revenue to our clients. Fast data is sort of one of the patterns that have emerged from the big data playbook. So at Google I/O this year, everybody was talking about the Lambda architecture, and then you'd go and talk to a Google presenter afterward, and they say, "Oh yeah, we've been using this for 4 or 5 years, and it's just finally leaking out into the open, something that we can talk about." It's like, oh, okay, well, there's a name for it now. We can actually talk about what this pattern is. In terms of what we're actually going to talk about for the TellApart personalization, I'll walk you through how we use the Lambda architecture to drive our retargeting product, specifically our bidder, which has very strict latency requirements, and then how we do data science using the Lambda architecture. So fast data, I said I'll address the buzzword side of it, so let's get that out of the way. Big data may be an inflammatory term for you, depending on how you feel about it. So big data to me means distributed systems and large amounts of data, having to process data that you can't handle with a single machine or even a small cluster. Large, powerful distributed systems. People don't necessarily feel the same way. Big data shows up in the fiction section in airports. So I don't want to be provocative here when I say fast data. I'm not trying to say like, oh, what TellApart does is really cool. We do fast data. It's one step beyond big data. What I'm trying to say is there's a concept that's emerging called the Lambda architecture, and it's big data but fast. So we need some way to talk about it. A buzzword is probably the best way that we can describe it because it's something that's going to stick. But I'm not trying to make it sound cooler than it is. I think the technology and how we apply it will speak for itself. What does fast data actually mean? So we said big data. Big data means data that you've collected over large periods of time. So I might train a model over everything that I know about a user for the past 4.5 years of TellApart's existence. And I could do that offline in batch. I could use MapReduce. I could use Hadoop. What won't happen is I won't have new events that are coming in every second be readily available to me. So I might train my models once a week, once a night, whatever it is with my Hadoop reporting stack. But I also want to be responsive to new events that are coming in. And not only that, but I want to be able to serve predictions using this data with extremely low latency. And by low latency, I mean milliseconds. I want new events to be ready to me in milliseconds. And so when I say fast data, it's the last two pieces. Having new events available to me and being able to serve them out or serve using those events with very low latency. How many people are actually familiar with the Lambda architecture and the stuff that Nathan Mars has been talking about? Okay. I'd say a quarter to 20% of the audience. So we'll walk through what the Lambda architecture actually is. The idea is you have data coming into your stack, and it's available both for batch processing and for stream processing simultaneously. So you have a new event that occurs, a user sees a TellApart ad, that's going to go into my batch layer, and my reporting stack will process that. It'll be available tomorrow when my batch layer runs. But it'll also be available to a speed layer. And then my serving layer is going to interleave data from both of those layers, my speed and my batch, and make it available to me. And that's a big data pattern that's been used throughout industry for a while now, but it has a name, the Lambda architecture. We can use that then to drive personalization. This is how we use the Lambda architecture at TellApart. On our predictive marketing platform, which is marketing buzzword speak, and my marketing person made me put that in here. We have a predictive marketing platform. What's a predictive marketing platform? Well, it's something that hasn't really existed in industry until recent years, and there's a few other companies doing very similar things to us. But we want to be able to make use of your customer data and help retailers make predictions about their users to serve them better, to serve personalizations, personalize on-site content, personalize ads, personalize emails, personalize everything about the experience of interacting with a retailer. What TellApart is going to do is do that in real time. So that's what we use fast data for. In our context, we want to invest many different types of events. So all the events that I just mentioned, interactions with ads, on-site interactions, interactions opening emails across different devices, congest them and ingest them all together, index them by user, and that way we can serve out personalized content on the order of milliseconds. So that was fast data. Let's talk about it in the context of transactional retargeting. Now, I know that many of you are familiar actually with ad tech and retargeting specifically because I met at least 3 people from competitors when I was talking to people earlier. I don't see Josh right now, our CEO, but thankfully we're very transparent as an organization, so I'm comfortable talking about our technology with you. I know clients are here too, so I'm going to just be totally transparent. You guys are engineers, I'm an engineer. Let's talk about what transactional retargeting is. How many people here either come from an ad tech background or know sort of retargeting and retargeted ads? Okay, so this will be pretty quick. Many of you know what marketing is. Marketing is the thing that annoys you. So advertising is, Pitbull selling you Bud Light, or the Corona ad that you have to watch for 30 seconds before you can watch your YouTube ad. I don't even know what this page was when I screenshotted it because I can't tell what the actual content is from the ad that they're trying to show me. So what ends up happening, well, you use ad block, right? That's what half the engineers that we talk to when we're recruiting them say is, well, who actually looks at display ads? Who clicks on ads? The problem with marketing is that it feels obnoxious. When people say advertising, advertising is a very charged word. It has negative connotations. Well, it doesn't have to be. So this is an email that I got from Nordstrom. I filter all my commercial emails. I scan them once a week, once every 2 weeks. This is one that I picked because I marked it to go to my inbox, and I start it. And later in the week, I went to the half-yearly annual sale, and I bought a couple pairs of shoes because that's what I do. Is once a year I buy shoes from Nordstrom online, and actually I meant to wear them as like a shtick for this, but then I realized that I actually bought these at Nordstrom several years ago at the same time through a half-annual sale. So that was accidentally convenient. This isn't marketing to me. This is information. I find this valuable. I wish it was more personalized and it could just show me the shoes that I want to buy and I could click on it and buy them. I would find that more valuable. But advertising doesn't have to be negative. If it's done right and personalized, it can be good. People will probably be aware of sort of how marketing people talk about advertising. There's different levels of specificity. Your audience gets smaller, you go down the marketing funnel. So there's brand awareness at top, demographic targeting. At the very bottom is somebody that's already been on a merchant's website, and we want to re-engage. So they're in the consideration phase. They're thinking about making a purchase, and one of the things TellApart wants to do is get that person to go back to a site and make that purchase if they're going to find value in it. So when I say retargeting, TellApart does retargeting. These are the types of ads that you might think about. These are all retargeting ads that I got in the space of 20 minutes while Googling for images for this talk. Some of them are more usable than others or more valuable than others. The PagerDuty one is not super interesting to me. I got it because I logged into PagerDuty to answer a page. And I think all the TellApart engineers are familiar with the PagerDuty ad. It's not even really that good of an experience to retarget people that are already logged in and using your product because it's just reminding you that you're answering pages. The Delta ad was after I purchased flights to San Diego for this weekend. Again, not super useful. I already bought my flight. The Panasonic retargeting ad doesn't even have a product showing in it. Okay, so there's room for improvement in the space of retargeting. Let's talk about TellApart transactional retargeting and how we approach the problem. So retargeting, a user is shopping, in this case on Neiman Marcus, goes to the Neiman Marcus site, maybe updates their shopping cart, maybe not, maybe looks at a lot of products, maybe not. They leave without making a purchase. Their shopping cart is empty when they leave the site. Why did they leave the site? Could be any reason. They might be in bed browsing on their laptop and are just tired. They might not want to go get their credit card. They might not have entered in the merchant site before. Maybe it's a big purchase. It is Neiman Marcus. Maybe it's an expensive purchase and they have to consider it for a while. Maybe they want to do comparison shopping. Time passes. The user's online and look, there's a TellApart Neiman Marcus ad. That sparks an idea in their head. They go back to Neiman Marcus' site. They put the product in their shopping cart. They make a purchase. Everybody's super happy. How does that work on TellApart's side? Well, you guys are familiar with ad tech. We use cookies. We drop cookies on the user's browser. We can identify them as an individual. We can match it up to what they did on the merchant's website. When we serve the ad, we participate in these real-time ad exchanges. And then we buy the ad, show it to them, drives them back to the merchant's site. There's a key piece here that isn't common to all retargeted ads. So this is something unique about TellApart's product, but I think of it as aligned incentives. This sort of the computer science game theory part of me talking. On the upper left, you have a network of our merchants, a bunch of logos that we work with. On the right, you have shoppers, and at the bottom is TellApart. The retailer and the shopper are aligned, right? The retailer wants to show things or to sell products to a user that they find value in. They don't want to waste their time. They don't want to give them a bad experience. It's easy to see. The user wouldn't be a shopper if they didn't find value in the shopper's products or site experience. TellApart is obviously aligned with the retailer, right? Like we want to drive value back to the retailer. We want to do that in the form of revenue. The way that we align our incentives is we operate on a revenue share basis. So we're a performance retargeting company. We only get paid for conversions that we drive to our retailers. And I'll talk a little bit more about our billing model when I get to how we make predictions and what our objective functions are for how we buy ads. There's a nuance here, which is we're also aligned with the shoppers. Because we get paid on a revenue share basis, we don't get paid by how many ads we show or how many clicks we drive. Instead, we spend our money and only get paid on a conversion event, which means that we are incentivized to buy as few ads as possible. So I don't want to show a user an ad when I'm retargeting if they're not going to go to that merchant site and make a purchase. So all the engineers in the audience that are using ad blocker, okay, you're not going to click on my ad and go make a purchase anyway. That's what you're saying with ad block. That's fine. I don't need to show you an ad. Josh would say that you guys do click on ads when you find them useful, and you just don't know it. So over time, as ads become more personalized, you'll find value in them. The incentive is aligned here because I don't want to annoy a user with ads. If a user is not going to go back and make a purchase that they wouldn't have otherwise made, then it doesn't help me to show the ad. So I have the user's interest in mind too when I'm doing retargeted ads at TellApart. So thank you for bearing with me through the boring stuff. Let's talk about the data science. This is the flow for our bidder that I'll be walking through, and we'll talk about this in 4 steps. When a bid request comes in, we'll walk through how we get features for a user based on their past behavior, how we predict the expected revenue that a user will drive to our merchant if we show them an ad. We'll talk about how we predict the auction dynamics so that we can set our bid prices correctly. And then there's a loop at the end, which is we need to calibrate our bids as well because we're operating in a real-time dynamical system. There can be events that our models might not be super responsive to, and we want to make sure that we're controlling our spending. Finally, we'll submit a bid response. So, okay, fine. Let's tie this back to the theme of the talk, which is to do all of this, we have 100 milliseconds. Like, okay, that's fast. But that includes when the bid request was sent from the ad network and when the ad network receives it. So really, we give ourselves 40 milliseconds. And that's 95th, 98th percentile worst case. So extracting the features of a user, predicting expected revenue, passing it through our chain of models, all that has to happen on our side, worst case, in 40 milliseconds. There's another piece, which is not only do we have to get the feature of a user, but in many cases, we have to get who that user is. So there's another database lookup there. There's actually 2 database lookups. That's hard. That's one of the challenges that attracted me to TellApart when I joined. So let's walk through. How do we get the features of a user? Well, first, we need to know what kind of features of user behavior we want. So there's a lot of types of predictions we might want to make about a user to serve retargeted ads. Maybe we want to know what a user's value is over their lifetime to a merchant, what their value is just today, or in our case, what the value is to our merchant of that user if we showed them an ad right now at this instant. Does it make sense to buy that ad for them? Other people solve this in many ways. I think probably the most common in ad tech is just using the probability of a click-through, the click-through rate. And that's, if you didn't have TellApart's infrastructure, maybe you're solving that as, what's the probability that this impression gets clicked given just the publisher that I'd show the ad on? Or what's the probability of a click just given what I know about the user, maybe calculated in batch offline, updated once a night, just stored in a cache somewhere. The features that we're going to use to do this are features of past behavior. We can categorize them maybe 3 ways, and there'll be other categories that we could talk about, but there's real-time features, things that we need to know from the bid request or things that are happening right now. Where would we show this ad? What's the vertical of the site that we'd show the ad on? There's events of merchant interactions. So how recently have they been on our merchant site? How many product views have they had in the last hour, in the last day, in the last week, in the last year? How many purchases have they made ever in the past day? How many items have they added to cart? How frequently do they go? How many sessions have they had? It's easy to extrapolate and start expanding out how many features we want to be able to make predictions. And then there's TellApart events as well. And these are sparser than the real-time bidding events, but there's more of them than merchant events typically. So how many ads have they already viewed? How many ads have they viewed in the last hour? One of the most common things to do in ad tech is frequency cap. Well, we can roll that into our models too. We don't have to have business logic controlling frequency caps. How many ads do they click? Do they click on ads? Do they just view ads and go on to purchase? Does that make them more or less likely to be incremental? So one way to solve this problem would be to build a custom infrastructure. And this is how TellApart did it years ago. So what do? Well, we'll have a batch layer that reads event logs, extracts features from them in MapReduce job, trains a model using those extracted features. And you can just have a chain of cascading jobs or a chain of MR jobs. Then we'll have a separate stack that's ingesting the real-time data and storing it about a user so that we can run the feature extraction all over again in a different stack so that in real time, when we're making these real-time predictions, we can predict user value. So you'll have to excuse me for looking at my laptop because I have probably 40 examples of why this sucks. The first one is this is really expensive to do. So it's fine initially. You can do this type of feature extraction offline in batch. It's not too bad, but it doesn't scale particularly well. So what do I mean when we're looking through event logs and extracting features to train our models? Well, let's say that we want to train over a year worth of data to predict whether somebody's going to click on an ad, whether somebody's going to convert on, after clicking on an ad. What that means is, per TID, I'm now grouping by that user ID. And I'm storing all events, probably ranked by time, ordered by time, and then processing them in a buffer on my reducer. That isn't going to scale beyond a certain amount of data, so now I start discarding data. How do I decide how to discard data? Well, I can come up with some heuristics. Maybe my assumptions change over time. Maybe I start ingesting a different type of information. Maybe somebody comes up with a really clever idea that depends on how many bids we've been receiving for a user. Okay, well, maybe I'll pre-process now and then run my feature extraction job after I pre-process that data. Okay, well, eventually we ended up with the next iteration of this, which is we should probably calculate feature summaries by day and then process both the feature summaries, the daily summaries, as well as what happened in the most recent day to be able to extract features. And okay, well that works for a while, except then we get into on-site personalization and we want to do sessionized features. So features of a user's last session. What happens if a session crosses day boundaries? Well, now my feature summaries get more complicated to extract. Okay, this is starting to get kind of painful, and I'm limited in the types of features that I can extract from user behavior. Not only that, but even with a relatively sizable Hadoop cluster on the order of 500 nodes, you start running into lots of problems in terms of jobs not being able to complete in a reasonable amount of time. Then you start having to have a modeling stack as well as your nightly reporting stack. You're maintaining 2 separate clusters, and it just doesn't scale super well. Let's say that we want to add a new feature or recalculate features. Well, we have these summaries. So we have to have a way to go over all time data, populate a new summary, dump it in, and then extract features from that and repopulate the features that we know for our models, retrain our models. Oh, well, maybe we didn't have that data stored in our speed layer. Okay, well, so now we have to start populating that. Well, when we built this, we didn't say maybe we'd want a batch processing job that could populate our speed layer. So we're using a memcache MySQL stack on the bottom here. Okay, well, maybe we should write that. Or when we find a new feature that could give a lot of lift to our performance and improve our real-time performance, maybe we say, okay, well, we'll start populating it now, but for users that haven't interacted with us in the past 24 hours, we're not going to have data for them. We're going to have to wait 2 or 3 weeks before those users even get data so that we can make predictions using that feature that we just said we found a lot of value in. Okay. I'm going to scroll through and see if there's anything else I want to talk about problems, but we can start to see the problems piling up here. I do want to say we were using cascading on the top, so Java cascading. And on the bottom, our front-end stack was all in Python. So not only do we have 2 totally separate feature extraction pipelines, one for real-time data, one for batch data, but they're written in different languages, so we can't even reuse feature extraction code. As we've been migrating to a Java front-end stack, I said we'd be transparent, so I've been embarrassed in terms of the bugs that we found with different feature representations between those 2 stacks. And I'm sure that you guys can find some compassion, so I won't have to feel too embarrassed up here. Okay, but there's a saving grace, which is we can go to a Lambda architecture. So Lambda architecture by Nathan Mars. I don't know how many people can see. If you can't see, I hope that you're familiar with the Lambda architecture. If not, I'll try to walk through it very quickly. So we have a batch layer on top, a speed layer on bottom, and new data coming in, new events coming in. New events get dispatched, yes? Sparse streaming and sparse batch? Spark. Ah, yes. Yes. Just says yes. The new data that comes in will go to both layers. And so in the batch layer where we're training our nightly models and doing feature extraction, we'll be able to have a master data set that gets split into a batch view for serving. And that will be combined with what we get out of the speed layer. So let's say that we want to do somewhat trivial analytics or something like that. Say, know how many clicks we got on ads in the past month. Well, we'd have 29 days available in our batch layer, and then we just have to process the speed layer. And at any moment in time, we could know exactly how many clicks we got, or count events, or statistics of events. The serving layer is what's indexing the batch view so they can serve fast. And so rather than store them as logs, we're going to index them so that we can retrieve them quickly by whatever key we want. The speed layer is also going to do that. The speed layer can also be just dropped completely. So if we want, there's a problem in the speed layer, there was a problem in data, or a problem with some way that we're representing something, we can drop the speed layer. We can either reprocess that from the batch layer, or we can just say, 4-hour data loss is okay. We processed it 4 hours ago in the serving layer for the batch. That's fine. So a Lambda architecture for machine learning. This is what TellApart is using. We have both event logs and Kafka feeding our speed layer. So our event logs are feeding our batch layer. We're still going to have a summarize layer and then feature extraction. So we'll be able to store feature summaries and then extract from them. To serve this, what we'll do is we'll have a materialized view faceted by user ID, so that when a request comes in about a user, and because we're doing personalization, everything will be user-centric, we'll be able to index by user, retrieve that very quickly, and then extract features from the top in the speed layer. Now, the feature API at the back, or at the end of this, is actually doing the true feature extraction. The speed layer is just feeding us events that have happened since the last time the batch has been updated, and then we're going to extract our features there. Thankfully, that's pretty lightweight because we're already pre-processing whatever extraction we can do or summaries we can do up here. There's then a model batch layer, which will just run our training jobs off of the exact same features that we're using in production for a user. So we no longer have issues with features being extracted through 2 different pipelines. Not only can we reuse the same code, but it's the same service that's providing that information for features. Sure. Yeah. Yeah. So the overlap is handled. So the speed layer has events in it. The batch layer, once it's updated, will have events that overlap with the features in the speed layer, the events in the speed layer. Everything in the speed layer will be sorted by time, and the batch layer will have a timestamp. So when we do feature extraction in the feature API, you just discard everything since that timestamp, and then interleave events after that. And we sort of have this feature topology. There's intelligence in the feature topology so that it does do some initial feature extraction, so that you're not processing everything in the feature API, you're just doing as much as you need to get the features that you need. So I guess there's more here. I'll point you at Jesh. Jesh, raise your hand. Jesh is the perfect person to go and ask questions about how we do the Lambda architecture with our modeling infrastructure, as he architected and deployed it. So he's the resident expert. Okay, well, I guess we talked about a lot of problems that we would have, the practical things, as well as being able to add new features, being able to come up with new use cases. I want to extend beyond retargeting one day and talk about all the different types of personalization we could do. With our old feature extraction pipeline, we were limited to just the features that we needed for retargeting. It was difficult to add new features or different types of features like session features. Recently, TellApart announced the acquisition of Freshplum, a company that does on-site personalization. And one of the first things we did when we brought them on board is say, okay, well, we should integrate our feature extraction pipelines. The types of personalization Freshplum was doing was showing users offers dynamically and predicting who would respond to an offer and who wouldn't respond to an offer. One of the Freshplum engineers said, okay, well, we should port this over, worked with us to use their features, which were session-based, from our feature extraction pipeline, They got the model up and running. They actually changed some of the features, which is why the AUC changes, but very similar performance, and it took about a week of dev time to actually do that. That's a positive result and a vote of confidence that we're going in the right direction to be able to extend out beyond retargeting products and start being able to model a diverse set of personalization products. Just some bullets in terms of what the Lambda architecture gained for us. One is the unified offline and online extraction. So having the speed layer as well as the batch layer. Robust and fault tolerant, much more robust than our old feature extraction pipeline. Feature engineering and iteration are really fast. So adding new features as easy as engineering the code for them, dropping them in, repopulating into that faceted view, and then also adding the code to do it in the speed layer, but that gets populated very quickly. So we can add a feature, train a model on it, drop it into production, and it'll all be populated there based on the data that we already have in the timeline coming in. You know, like we saw with the Freshplum model, it supports features that are otherwise expensive to deploy. So if we had wanted to, in the old way of doing things, regenerate session-based features, we would have had to start from scratch and reprocess all of our feature summaries to be able to do feature extraction on top of. Here with the Lambda architecture, all we have to do is write the code to do it once, and we don't have to drop our tables anymore. We have all that data stored in our databases. So we can get features for users, but what are we going to use these features for? Well, what we want to do is be able to predict something about users so that we can show ads selectively. DJ Patil was here a couple of years ago at TellApart to give a tech talk. He called data jujitsu, and I think one of the things is relevant to building a retargeting strategy. So we're solving retargeting in an interesting way. We're performance oriented. We operate on a rev share model. It means we're going to solve the problem differently than other retargeters do. And it's a non-trivial problem. DJ says smart scientists don't just solve big, hard problems. They also have a knack for making big, hard problems small. Okay. One day I aspire to be a smart scientist, so let's give it a shot. There's a bunch of different valuation strategies we could try for retargeting. So we're a venture capital funded startup. We could always raise more money. We have money in the bank to spend on ads. One thing we could do, which is the second bullet point, is we could bid infinity in these real-time auctions. So we know that we're going to get credit for revenue when we drive a user to a sale. Well, how do we make the most money? We just show everybody ads all the time. That means that any possible incremental sale we could drive, we would get credit for. We don't even need to do modeling. We just need to keep raising VC funding. Okay, well, that's one take you could take, and maybe that's a good initial take. You know, start a product, sell it, and then build out the modeling infrastructure once you know you can sell it. A take that some retargeters do is pass the buck to your client. So what does that mean? Well, it means you expose a big dashboard with all sorts of knobs, and you say, I have different audiences that I want to target, and this one I want to target at a 45-cent cost per click, and this one I want to target at $1 cost per click. People that have updated their shopping cart are worth more to me. Also, if you're new to file and haven't purchased before, I want to spend more on you, but only in the most recent 7 days. After that, then I want to spend the same amount, and we could build this huge, complicated dashboard to do exactly that, but that doesn't let us be intelligent with data. Okay, let's talk about the real ones. We could bid proportional to a user's value. So I might have a frequency cap of some finite number of ads. I know what a user's value is to me. I split that across K ads, and I bid the user's value divided by K. I could bid proportional to the probability the user's going to click my ad and bid out on a CTR basis. I threw this up here for Josh. Josh and I both come from Michigan, where we worked on sequential decision making. We could formulate this as an MDP or a POMDP and solve for the optimal policy. That is not making a big hard problem small, adding a layer of complexity. So what we do is we find users' value based on how incremental they will be to our retailer and predict how much revenue they're going to drive us. So there's a few terms that I want to drop for the people that are not familiar with ad tech. CPM is the cost per 1,000 impressions. We could bid out on a CPM basis. That means that ads are valuable to us when they're displayed. We could build that way. CPC is cost per click. So if you're thinking about how to measure cost per click of an ad, CPA is the TellApart model. It's cost per acquisition or cost per action. Ads are valuable when they lead to an action. That's the TellApart basis. And we're going to, like I said, charge a revenue share for each conversion. So that's how we're going to bill out. That's how we're going to model our value. So the value of a TellApart ad. Let's make an equation. The expected revenue of a bid request is going to be congruent with the probability that that bid leads to an impression times the probability that that impression leads to a click times the probability that that click leads to a transaction times the expected revenue of that transaction. So we like to call this the TellApart equation on the bidding side. We can simplify it slightly and just assume that we only care about the value and cost of ads that we show an impression for as we're doing our predictions. Well, this decomposes very naturally because this is just multiplication. So let's make a chain of simple models, and we'll predict each one of these independently. We'll predict the probability of a click on an ad, the probability of a transaction given a click, and then the expected revenue of that transaction, all of these per user. We can even make this simpler. So rather than predicting the probability of a click or probability of a transaction directly, instead we can train a model that ranks users and then fit that to probabilities, and that's even nicer. How does TellApart do this? Well, there's lots of ways to predict probabilities. We like to throw data at a problem and be intelligent with our feature selection. So we use naive Bayes to predict both probability and probability of click and probability of transaction. Expected revenue is a very simple regression. Once you have those values, it works well for us. So let's talk about how well it works. When we rank users by value, 85 to 90% of clicks are made by bids in the top quartile. And I actually pulled this late last night, and I thought I had pulled it wrong because the top quartile is a very large amount of users. 25% of our bids would, it takes 25% of our bids to reach 90% of clicks. But because it was late at night, I wasn't thinking clearly, and 96% of our conversions are made by bids in the top quartile. So yes, we're effective at picking out who the valuable users are. And let's say we only want to show ads to a quarter of users. Well, okay, we can account for 96% of conversions. And I'm not cherry picking this data. This is actually a very pessimistic view of the data, because I pulled this for a merchant that we're showing many, many ads for because of their revenue share model and the way that they want to show ads. So each merchant is going to be totally unique for TellApart. Some merchants will have a low rev share, low AOV, and ads will be relatively expensive to how much revenue we could drive them. We show very few ads on their behalf. Some merchants, we might show a lot of ads for, merchants that work very well with our model. So what kind of merchant works really well for our model? Well, merchants with high order values that have users that really like to click on their ads and engage with their ads. That's a very good fit for us. We can drive a lot of revenue for those types of clients. We actually work better than that. 80% of our conversions are just from the top 10% of bid requests that we receive. So we're good at picking out who's going to convert and who's not. And I mean, there's some theoretical limit here. How well could we predict? Well, I like to believe in agency and free action, so I don't think that I can tell exactly what's happening in your mind. There's going to be some information that's impossible for me to recover. So I don't ever think that we'll get to 100% of conversions by the top 1% of users, but there is still a lot of work in feature engineering that we can do to get much better than this. Predicting the auction environment. So we know how to get features for a user, and we know what we want to value a user at when we're bidding in real time. But just because I know the value of a user doesn't mean I know how to bid on a user. So if you're familiar with auctions and mechanism design and game theory, let's talk about how these RTB auctions actually work. So there'll be a number of publishers working with an RTB exchange, and these ad exchanges are DoubleClick, Yahoo, PubMatic, AppNexus, Facebook. The bidders on the bottom will be getting bid requests from these publishers for ads that are available as a user's browsing a site. So we'll have a bidder that's TellApart. We'll also be competing against the exchange itself, which is seeing much more information than we see. And then we'll be bidding against our competitors, other people that might also want to show this user ad in real time. So these auctions are second price sealed bid auction. So if you read the literature, you know that a second price sealed bid auction is a Vickrey auction, identified after Vickrey characterized it in the academic literature in the 60s. And a Vickrey auction has a very stable Nash equilibria. Everybody bids your true value. This is why eBay has a second price auction. Well, eBay isn't sealed, so maybe it's not a Nash equilibria, but a second price sealed auction is a very optimal auction. Everybody's incentivized to bid their true value. You let the auction decide what you're going to pay. There's no way to game it. Well, that's not entirely true because these aren't exactly repeated auctions, but they're not one-shot auctions either. I know that if I see a user and I get a bid request for them, there's a very high likelihood I'm going to get another bid request for them, possibly simultaneously with this other bid request. So if you think about how a web page looks, there's multiple ad slots on that page. To my front ends, when I get one bid request, I'm probably getting at least one other bid request, maybe another one. Well, that's true for some of the auctions we participate in, not Facebook, where we get one per 22 hours for newsfeed, one per possible impression on right-hand side, shown 5 seconds apart, not milliseconds apart. But that raises another good point, which is I can find the user that I want to show an ad on multiple exchanges. So I'm not just limited to the exchange that I'm bidding on right now. Maybe I can find the user more cheaply on a different exchange where some of the bidders I'm competing with on this exchange don't exist. Okay, well, there's also information leakage. So maybe I find value in other participants in this auction not knowing how I'm bidding on this particular user, or maybe I can bid in an intelligent way to get information from other participants to know how they're valuing this user, and maybe I even want that to go back into my own models to know, oh, people think that this person's really good to show ads to. Maybe they're seeing information I don't have. Maybe they're working with merchants I don't have. Maybe they're getting interactions that I don't have. Okay, so we can't just bid based out on our true value. One of the other things that we've seen on partners that we work with are sliding fees. And so this happened more frequently years ago than it does now, although we've seen it recently. You work with an auction, we're tracking market competitiveness, and you'll see how we model this in a second. But if you're changing how much you're charging a bidder based on how much they bid, then it's no longer a second price auction, it's acting more like a first price auction. So you're violating that assumption. Finally, there's auctions for right-hand side ads on Facebook, and this is actually going away, but they let you bid back for multiple slots. Okay, well, that's awesome, I can show multiple ads. Oh, but if I bid the same value for both slots, I second price myself because they don't control for that. So now I bid out 2 $1 ads and I ended up paying $1, whereas if I bid 10 cents, maybe someone hasn't even bid anywhere near me. I pay a lot less. Okay, well, so now maybe I want to model that too. Okay, so we know how to value a user. That part was actually relatively easy. How do we bid in these auctions based on the value of our user? Okay, well, we said already we could bid infinity. Bidding infinity will still maximize our revenue. So we'll win every impression, get every possible click, and naively we'll just assume for the sake of argument that we're not going to turn people off from that merchant over time, that really does maximize revenue. A corollary to this is bidding our true value will maximize our profit. So let's assume that we don't know all the things I just talked about, how auctions are broken. If I bid my true value and I win at a lower price, and we'll assume a true second price auction here, I'm now maximizing my profit. So let's think about this. How could I make more profit? Well, I can't bid higher than my true value because I run the risk of winning at more than my true value, and therefore spending more on that ad than I want to, which means that I'm incurring a loss. So I'm losing profit there. I could bid less than my true value, but that means that if somebody else outbids me, I'm no longer showing that user an ad when I may have found value from showing them an ad. So deviating from that, assuming that we have an actual optimal auction, doesn't improve my profit. In fact, it hurts my profit, so therefore bidding our true value maximizes our profit. Winning at our true value maximizes what I call our affordable revenue. So I have a value for a user, and if I can manage to game the auction in expectation on average to win at my true value, that means that I'm now maximizing our revenue. We're a venture capital funded startup. We're in growth mode. We want to maximize revenue. Okay, so we now have to figure out a way to win at our true value. I'm not going to actually address this, but we don't only just want to win at our true value, we want to minimize the variance as we do that too, because any variance that we incur when we're winning at our true value is going to be less efficient for us. So how do we win at a target clearing price? Well, we model the competition. Okay, so what do we know about our competition? Well, one, we know that many publishers that are competing in the marketplace are bidding out on a CPM basis and just want to get lots of clicks. So they're going to know which sites drive lots of clicks and have high native click-through rates and which ones don't. We can also just look at clearing prices on inventory. People value the name of the Washington Post a lot more than Daily Motion. I picked these because Washington Post has one of the highest clearing prices for us. Daily Motion has a very low clearing price. When we model how we bid on each site, you'll see very different behavior based on how other people are valuing that inventory. And not only that, you'll see it across different bands of bid prices. This is a plot with all valuable information removed from it so that all of the competitors in the audience don't know exactly what we're doing here. But what this is and I tried to get that one passed, but it didn't fly. What this plot is an average clearing price for one of our participating networks. So this is across all of the bids that we're generating on that network. The network is double-click, so it's fairly expensive. You can see some trends emerge. So there are trends that are very periodic, and where I've identified with the highlighted bars below, you see a sharp spike in the win price, and actually just prior to that is the lowest price that is clearing per day, with one exception. Okay, so there's definitely information that can be gained and learned from watching the market closely. There's lots of features of environment that we can take, and so we can make this prediction. And how do we want to predict? Well, we just want to take desired win price and pass in all of our features of environment, not users. So this is different from the types of features that we were extracting with the Lambda architecture. This is our environment now, which is much easier to get features from, and predict a bid price to win at that price given where the environment is. So let's talk quickly about two ways to do this. I'll call them the easy way and the good way. So the easy way is the first thing that you would think of, and I was extremely proud of thinking up this name. I do not know whether this is a real algorithm or not. All right, I thought it made sense. Local linear isotonic regression. What do we do? Well, let's split up our desired win prices, do local linear regression in between. We'll make it isotonic to make sure that we sort of normalize what we should. If we have a higher win price, we should have a higher bid price. That's the isotonic part. And we can model this across more than just win CPM and bid CPM. We can include features of environment. Okay, well, curse of dimensionality is going to catch up to us there as we start adding more features of environment. This is going to get hairier and hairier, and the data will get much sparser at the win prices and bid prices that we actually care about, which are at the far right of this, way beyond the data that I've shown you here, because those are going to be our most valuable users, the one we want to pay the most for, the ones that are most likely to convert. And if we start doing poorly up there where there's sparse data, it means that we're not making nearly as much revenue as we could for our clients. The right way. Well, a mixture of Gaussians ends up working out really well. We tried a bunch of approaches improving on our existing algorithm. Mixture of Gaussians, we're going to identify a number of clusters. We're going to learn those clusters, and then we'll be able to make predictions sharing information across those clusters to leverage the trends that we can identify in features. Where's Jung? Oh, there he is, next to Josh. Jung rolled this out. I'll do this part first. This had a big impact, both to revenue and the performance of our ads. This was a great win for us. Now I'll go back and say, you know, sometimes the right way to approach a problem is say, what's worked for us in the past? Well, just having a very simple win versus bid model had a big impact for us. Okay, we know that there's a lot more features that we could include in that model. Let's double down on something that's had impact for us and spend the time to do EM over MapReduce and cascading and many, many cascading steps to get a better model out and to realize the gain of improving our model there. The last step, calibrating our bid. So before I step off of the slide, we have features of every user. We can predict expected revenue. We can predict the auction environment. We know how to go from just knowing about a user to how we want to bid in this real-time ad exchange. Well, we're not perfect. So, like, great, we're doing a good job, but the real world is messy. So these auctions are non-stationary. People change their bidding strategies all the time. A competitor advertiser might get $1 million more in budget from a really big brand and want to buy every single impression the last 2 days of a quarter. We know that we have biased data in many ways. The way that we're collecting data is based on our current bidding strategy. Okay, well, all that data is feeding all of our models. How do we get data not using our bidding strategy? Well, that would be really expensive. There's ways to do it, but let's assume that our models aren't perfect. I think that's a safe assumption. So we probably need to also make sure that not only are we bidding according to all these predictions that we're making, but we're also sanity checking the real-time performance of our system so that we don't wake up tomorrow and have to answer why we spent $1 million overnight. That's not a fun conversation to have. We also want to bid, like I said, to maximize affordable revenue. So we don't want to spend too little because now we're sacrificing top-line revenue for profit. We also want to make sure that we don't spend too much. We're not bidding infinity so that we can afford the revenue that we actually drive to our clients. PID controller. This is something we could do. We have our plant process. I got tired at the end, so I didn't recreate this chart. I just took it from Wikipedia with a Creative Commons license. Our plant process is, in this case, our bidder. Y is the performance of our bidder. We're looking at a target value and calculating the difference, which is our error term. That error term will feed into a proportional gain controller, proportional gain, an integrative gain controller, and then a derivative gain. We'll sum that up together, and that will be our control signal. So we bid too much, we tone it down with you. We bid too little, we crank it back up. We have this knob that's going to guarantee we're bidding effectively. We have to talk about what our target is. Our target is making sure that we're maximizing revenue. We know how much we should be making. We can compare that to what we think we're doing with bidding and say, okay, we need to make more, we need to make less, based on whatever client we're working with. What does it actually look for TellApart? Well, we can simplify. So what we do is we discard the integration and the derivative terms, and we just do the proportional gain. So on the right is our production environment. I call out Taba. Taba is an open source stack that we use for tracking real-time data in our system across our thousands of machines. Taba is going to give us a count both of our real-time spend and our revenue. We can compare that to our target, calculate an error term, and we'll just have proportional gain going back to the controller. Crank it up to increase spending, crank it down to decrease spending. Okay, well, what do we do when we increase spending and decrease spending? Because we just had this whole model chain that told us exactly how to spend based on our predictions. And now I'm saying, well, our predictions are wrong. We need to spend more or spend less. Okay, so let's do that strategically. When we want to spend less, well, we don't want to spend less than our true value. And the best information that we have at our disposal is the predictions that we make. The less we know about a user, the less confident we are in our prediction. So we could lower bids across the board. We could lower bids on some users, or we could just stop bidding entirely. if you look at how cost and revenue is distributed, you're going to find that you spend disproportionate amounts on low-valued users. Those are the users that you know the least and are also unlikely to drive revenue to a retailer. So who do you know the least? Well, it's someone that bounced from a merchant's site after visiting a single page or viewed a single product or was seen years ago. People that you see going back to a retailer, interacting with your ads, opening emails, those are people that you know a lot about and are also valuable. So what we do is we threshold. Depending on where that control signal is, we'll stop bidding. That's good, that gets our costs in line. And there's a limit to how much we'll threshold, and then we do intelligent things after that. I'm not gonna talk about the other intelligent things we do there. Instead, I'll distract you and say what happens when we spend more. When we spend more, what happens is we're just gonna bid more across the board. So now it's something that we have an opportunity to optimize down the road, but what happens when you wanna increase your revenue? Well, unfortunately, the reality is for the users that we know the most, we're essentially winning exactly when we want to, and bidding more isn't going to help us win anymore. We were at a talk at LinkedIn a while ago with someone speaking from ad tech, and she was presenting and saying that she was really concerned because her bidder was not winning at 100% even when she was bidding infinity. And someone said, well, what is bidding infinity? And she said, well, we bid out $20 CPMs. And we kind of looked at each other and said, $20 CPM is nowhere near close to how valuable some of these impressions are actually worth to our retailers. We can increase beyond the highest bids that we make, but it's not going to change our win rate. Instead, what we need to do is bid on the mid-valued users and the low-valued users more if we want to noticeably impact how much we're spending on ads. Now, remember, the top quartile drove 96% of our conversions. The top 10% of users drove 80% of our conversions. There's still value in those mid-valued users, and we'll be able to get incremental conversions from them. Definitely something we want to play with down the road. How does our bidding strategy work? Well, rolling out this this way of controlling thresholding moved our spend to be much more aligned with where our revenue curve is. So there's 4 curves here. I unfortunately am colorblind, so I'm not going to be able to dictate you the colors, but the dashed line on the left is our bids, how bids are distributed across ranked users and ranked bids. And it's a percent of total going up. So you can see our bid distribution, you can see our revenue distribution. As we increase the rank of our users, revenue is going to increase much more quickly from the right. Our spend used to be somewhere in the middle of those 2 lines. We weren't allocating our spend completely efficiently. Rolling out the strategy allocated it much more in line with where we're actually driving revenue. So we see a big gain in efficiency, and therefore a big gain in top line because we can spend more money on our users. So control is hard. Our strategy is to prefer improving our model chain. So the better we can make predictions, the less load we need on the control system, and the more we can rely and tune the control system just for very strange periods of time. Something happens in the marketplace, people are dumping money, our predictions are totally off. Let's rely on our control system then. Day to day, week to week, we'd really like to just have accurate predictions so that we don't have to wait for the lag time of bringing our control system up and down. Every time we have to change how we're bidding based on that control value means that we're inefficient and there's an opportunity cost there. Unpredictable market dynamics. Some things you're not going to be able to predict. That's what we want to rely on the control system for. The predictable market dynamics and the inaccurate user value models are the things that we'd like to spend time predicting. And like I said, pushing responsibilities up to the models makes everything more efficient. So that is our secret sauce. The one interesting piece that we didn't talk about is the database lookup for the user's identity. Identity is a modeling problem all in itself. So you have different cookies across different devices. There's some ground truth that you can use to identify a user. Well, if they open the same email to the same email address on their phone and their desktop or their work computer and their home computer, you can start to get these signals of identity. They log into a merchant's website. Well, okay, but what if they use their mom's computer and then that was only once and then your mom is browsing the internet and that's not you and she's seeing personalized content on a merchant site? That wouldn't be good. So we should make a prediction there and calibrate what we know about a user's identity. Anyway, there's lots of extensions to use modeling there, and maybe that'll be a future talk. So that's just bidding, identity, products that we show in ads, something else that we haven't talked about. How do we populate these ads that we show to user? Well, we want to make sure that we show the most interesting, engaging content. Sometimes that's products that they already viewed. Sometimes that's recommended products, products related to products that they purchased, products that are recommended related to what they viewed. There's also a lot of really cool stuff that the data platform, about the data platform that we use to power all of this. So wrapping up, TellApart by the numbers. We handle 5.3 billion requests per day. At peak traffic, we're handling right around 100,000 queries per second. That is in August. November and December will be a much different story. We say that we lift online revenue for our partners by 10% or more, and we have case studies to prove that out. As of December 2013, the last time we talked about public numbers, we were at a $100 million annual run rate on revenue. And one fun fact is we claim credit for driving 1% of Cyber Monday e-commerce in 2013, and we're looking forward to outdoing that in 2014. TellApart has won every head-to-head test with a competitor based on performance numbers, and so I will say Mark Twain is famously attributed for saying there are lies, damn lies, and statistics. This is not a statistic. This is incremental revenue that is measurable both by our own A/B testing and by our merchants' attribution models. So this is not a statistic. This is us winning every head-to-head contest that we go up against. To wrap, I'm running up on an hour. The philosophy, the learnings that we've had at TellApart, I'll just run through them. I was thinking about skipping this, but people told me that this is one of their favorite parts of the meetups, is just hearing anecdotes about what we found valuable. One anecdote. Product will initially dictate the platform that you build and your infrastructure, but the way that you build that infrastructure will dictate what's possible down the road. So TellApart has had an opportunity to use the Lambda architecture and re-infrastructure our entire suite of products. That's awesome. Not every company will get the opportunity to do that. Some companies will take years to do that. We, with a staff of 30, 35 engineers, were able to do it relatively quickly and from scratch. Build good infrastructure because it's going to dictate what you can do down the road. Every time a product manager or a salesperson or an account manager comes to you and says, wow, it would be awesome if we could do this, or someone wants to include this in their model, could we test it? They've heard really great things about looking at features this way. Wow, if feature engineering is really easy for you, it'd be nice to be able to just drop that in. If someone wants to do email targeting based on what happened seconds ago, it'd be nice if your modeling platform could predict whether or not that user wants to receive an email seconds after being on a merchant's website. The way that we like to think about what to tackle here and what to prioritize with a small engineering staff and a very strong business is the expected value of doing something is what you think the impact could be multiplied by the probability that it's going to work. There are some high impact things that you might not be staffed correctly to do. There are some low impact things that have very high probability of succeeding. You want to work on the things that will succeed and that will have impact on the business. Simple models chained together. This is something that we say every day to each other. Decompose the problem, the hard problem, into a chain of very simple models that are the right models to work on. Find simple changes with big impact. At TellApart, this is more of a TellApart philosophy rather than a data philosophy or a machine learning philosophy. Data wins arguments at TellApart. The company works based on data. Facebook is known for saying code wins arguments. At TellApart, it's data. We want to make data-driven decisions. And transparent and completely aligned objective functions. So one of the nice things about our model is that we bill out on click conversions. Click conversions are auditable by our merchants. So there's no funny business. They can match up who's clicking on an ad and who's making a purchase and audit the exact numbers that we go back to. Also, it's very easy to predict on our side, so we can predict exactly what we're billing out for. Just a few green fields. We have an identity network. This is something that we join across all the information that we see. We join across all the different cookies, client logins, ad exchange cookies, information that we get from Facebook, private site exchanges, mobile apps. Well, there's a lot more modeling that we could do to find either lookalikes, find the same user, join offline to online data for our clients, beyond what we already do. There's lots of opportunities to apply data science here at TellApart, and we're just starting to scratch the surface. Speaking of scratching the surface, email is a very open problem right now. Etsy serves very beautiful emails. The personalization is lacking. Amazon serves very personalized emails. I don't think anybody would call that Amazon email beautiful. Our merchants deliver beautiful catalogs to their clients that are not personalized. Why can't we personalize that content and make it feel like it was human curated? Also, why can't we send an email whenever a user is going to find the most value in it? And why can't we send the types of emails that a user is going to find the most value in? Those are all things that we could predict and model based on the data and the infrastructure that we've built. On-site personalization, also completely untapped. This is just me looking at sites. On the right is my Amazon page in my work browser. And then in an incognito window, it's totally different. Well, the Neiman Marcus page just stayed exactly the same. And I maybe want to find stuff on Neiman Marcus, but I'm not going to look at those things. Every solution that we do build will have a few things in common. One is we will find ways to apply fast data to do things that our competition can't, and that will drive incredible value. I think everything that we've seen in e-commerce shows that recency, how quickly you can react to a user doing something to be able to personalize something, drives a lot of value. And a fast data infrastructure is going to be able to power those personalization products. The reason that I show this slide again is because of the aligned incentives. We're a big performance-driven company. Every product that we build will also be aligned both with our users and with our clients. Finally, I'd be remiss if I didn't spend 1 minute doing some recruiting for TellApart. Fast data, hard problems, insanely great team. On our website, it says big data, hard problems, insanely great team. I think it's time that we updated that. All of these things are true. Fast data, we just talked about. Hard problems, there are some really challenging problems that our engineering team and our biz team solves every day. The insanely great team is very true. When I joined TellApart 3 years ago, I joined primarily because of the strength of the team and the types of problems that they were solving. I'm here today because the team has gotten stronger over the years, and it's really fun to work with the people here in this office day to day. So as you make your way out, or after we answer questions, please find the TellApart engineers, find the TellApart biz people, talk to them, just say hi. I think you'll find that they're pretty awesome, and maybe TellApart is not in your roadmap or what you're looking for, but I hope that you found today somewhat useful and interesting, and you'd be able to tell your friends that we're good people. I think down the road, TellApart is going to be a brand to have been on an engineer's resume. I think many of us really believe this, that the types of things that we're doing between these walls and just starting to surface out will be something that a lot of people talk about, and you might be doing your friend a favor or yourself a favor if you visit our careers page down at the bottom, tellapart.com. Thanks, everybody.